Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. In this lecture, we are going to see the working of a centrifugal pump and the concept of priming. We are in the second module where we are studying boilers and turbines. In that case, we are particularly studying the centrifugal pump. A centrifugal pump, we want to see the basic definition. It is a device which will convert the mechanical energy into hydraulic energy. So far in the previous lectures, we have studied how a hydraulic machine will work. First of all, we will try to remember what is a hydraulic machine. A hydraulic machine is a device which converts one form of energy to hydraulic energy, any kind of energy. Like there are two types. Hydraulic energy is converted into mechanical energy and mechanical energy can be converted into hydraulic energy. This is how any machine which converts hydraulic energy into mechanical or mechanical to hydraulic can be called as a hydraulic machine. This is called a hydraulic machine. In these hydraulic machines, there are two types. First one, turbines, which we have already studied in the previous lectures. There are different types of turbines like open reaction turbines, open closed turbines. Different types of turbines are there. So turbines are the devices which will convert the hydraulic energy, that means the kinetic energy of the water that is stored in the reservoir. Okay, we will have a reservoir where water is stored at a height, which we call it as head. And this water, when flown through a pipe called penstock, it will have some velocity. So due to this velocity, it has possessing some kind of energy. So this is called as hydraulic energy. This hydraulic energy, when it is converted with the help of this turbine, this hydraulic energy can be converted into mechanical energy. That means rotational power. This rotational mechanical power can be given to a generator where the generator can produce electricity. Now, so turbines are the devices which will convert hydraulic energy into mechanical energy. Whereas pumps are the devices which will convert mechanical energy into hydraulic energy. That is very opposite to the turbines. So pumps and turbines works in opposite manner. In turbines, the hydraulic energy is converted into mechanical energy. That means we will use the velocity of the water which is stored in the reservoir, and this velocity will be converted into rotational motion, and this rotational motion is used to run the generator which will produce electricity. So here the end product is electricity. Whereas in pumps, we will give some mechanical energy by driving the pump with the help of some mechanical energy that is being generated from a motor. This mechanical energy is converted into hydraulic energy. That means we are going to increase the pressure and velocity of the water so that we can pump the water to a certain head. So pump, the working is exactly opposite to turbine. Now, let us try to understand there are different types of pumps are there. There are reciprocating pumps and centrifugal pumps. In the previous lecture, we have seen the working of a reciprocating pump. Now in this lecture, we are going to study how a centrifugal pump will work. Now see here, let us try to understand the basic definition of a centrifugal pump. A centrifugal pump is a hydraulic machine that converts mechanical energy into hydraulic energy. It does so with the help of a centrifugal force acting on the displaced fluid. Now, when we see this definition, it all deals with the conversion of energy from one form to another form. Now, the hydraulic energy and mechanical energy. These are the energies which are being transferred from one form to another form. So here we have a separate kind of technique for converting these energies. Like I will write here, in pumps, what happens? There are two types of pumps are there: reciprocating and centrifugal pumps. In reciprocating pumps, we know in all pumps the the mechanical energy is converted into hydraulic energy. Mechanical is converted into hydraulic. So this is what happens in any pump. Now we have separate techniques in reciprocating pumps as well as in centrifugal pumps. We need different techniques in order to convert this energy. That means the mechanical energy is to be converted into hydraulic energy by using different methods. In reciprocating pumps, we will use a technique called crank rotation. Here the crank rotation is converted. That means using this kind of technique or method, we will convert the mechanical energy into hydraulic energy. We know in a reciprocating pump, we will have a closed cylinder inside which we will have a piston. This piston will have a piston rod which is attached to a crank wheel. Okay, if this crank wheel rotates, we have a crank, and this is connecting rod, this is piston rod, and this is crank. This is crank. So when this crank wheel rotates in clockwise or anti-clockwise direction, then what happens? The piston will be moved to and fro. That means the piston can move towards the inner dead center and also towards the outer dead center. Now in this manner, with the rotation of crank, we can actually convert the mechanical energy into hydraulic energy. Now in case of centrifugal pump, we will use centrifugal force. We will use centrifugal force for conversion of mechanical energy into hydraulic energy. Now, how this centrifugal force is used to convert one form of energy into another form? Now, we are going to see that in this working. Now, in this picture, we can see there is a blue colored device. This device is called a centrifugal pump. See, in this entire thing, we have two parts. This part is the centrifugal pump, inside which we will have some mechanical moving devices, and the remaining part is nothing but a electric motor. So this thing is motor, electric motor, which is connected to power supply, where it can produce rotating motion. That means mechanical energy. So the mechanical energy will be given by the electric motor. And here, this device, this is called pump. We'll see what are the different parts of the pump so that we can understand how does the pump will work. Okay. Now, any centrifugal pump will have these two parts which are coupled together. That means these two are coupled here. We can see they're attached with the help of nut and bolt. And using this electric motor, we can generate mechanical energy. This mechanical energy in the form of rotation can be supplied to the pump, and the pump will move the water from one place to another place, or it can increase the pressure and velocity of the water. Okay. Now, and this diagram, this is the block diagram of a centrifugal pump. It is also a sectional view of the centrifugal pump, where we can see the inner parts and how their parts are arranged inside the centrifugal pump actually. So we'll study the working. Before that, we are going to see what are the different parts of a centrifugal pump. We have three main components, that is shaft, impeller and casing. Now let us try to understand what is a shaft. A shaft is a cylindrical rod which is connected between the impeller. That means it is connected here. Remember, we are seeing this cross-sectional view. Okay, the shaft is perpendicular to this screen. This shaft is connected to the electric motor. In the previous slide, we have seen. So here in this diagram, we can simply say this is how a shaft is placed. So it is placed between the shaft, the centrifugal pump, and the electric motor. Now, this is where we will connect the metallic rod, that means shaft. What is the function of this shaft? Shaft is used to transmit the mechanical energy from the electric motor to the the centrifugal pump. Okay, so shaft will connect, transmit, shaft will transmit power. It will transmit power from the motor to pump. Okay. Generally, we used to call this in regular terminology or in household purposes. We will call this device which will pump water from one place to another place. It is generally called as motor. But why it is called motor? Because it has a motor attached to a pump. This pump might be a centrifugal or reciprocating pump. Now, shaft is a device which will transmit the power from motor, that is electric motor, to the centrifugal pump or a reciprocating pump. Okay, shaft is a device which is rotating. And the second device is impeller. So impeller is a device. In this picture we can see clearly, this is impeller. This is very similar to the construction of a turbine wheel. We used to call this as turbine runner, where we will have a circular disc on which we will have some vanes attached. Okay, these vanes, when water flows over them, they can create rotatory motion. See, the vanes are curved in shape. They are not flat or perpendicular. They are in curved shape, so that when water touches this impeller or runner, in case of turbines, they will tend to move or they will rotate. Now, here the working is entirely opposite to the turbine. So, in a pump, when we give some mechanical energy to this runner or impeller, this is not runner anymore, this is impeller, because we are studying pumps. So, this impeller will rotate in clockwise or anti-clockwise direction, depending on the orientation. So, this impeller will rotate so that the water inside this casing, okay, this is all filled with water. Entire thing is filled with water. So whenever this impeller rotates, the water also rotates with the impeller in circular motion. Okay, now with this motion, the pressure and velocity of the water can be increased. Okay, and the third part, we have a third part here, casing. That means this entire thing which is closing the impeller and entire shaft arrangement, this entire thing is called casing. So the function of a casing is to hold the water. So whenever we are increasing the pressure and velocity of the water will move at a very high speed. Because we have a rotating impeller, it will split the water in all directions. So in order to avoid the splashing of water in multiple directions, and also not to lose the pressure and velocity of the water, we have to use a casing. So casing is a closed device which is in circular shape, and in this picture we can see this thing is called casing. Okay, this part which is in the circular shape, and inside which the impeller is present. This part is called casing, and casing will use to protect the water from splashing, and also it is used to control the temperature and pressure. Okay. Now, these are the three different parts: shaft, impeller, and casing. And then we'll try to understand the working of a centrifugal pump. How does a centrifugal pump works? So, first let us try to understand this block diagram so that we can simply understand how it works. Okay. Now, I'm starting from here. Here this is called a foot strain valve. This is a foot strain. That means this is a pipe made up of metal, and this pipe has a filter attached at the end. Now what is the function of this strainer? The strainer will filter unwanted particles entering into the centrifugal pump. Okay, any unwanted particles like stones, mud, sand, etc., they will be filtered here so that they do not enter into the centrifugal pump and inside the casing, so that they won't cause any damage. Okay, when we switch on this pump, a large amount of suction is created. Due to this suction, not only water but also other particles like rocks, mud, etc., will go into the casing, so they may damage the internal parts. So that is why we have fitted a strainer. The strainer is like a filter which will filter everything, like it will filter the water. So this entire thing is submerged in water. Okay, so the strainer pipe is submerged into the water, and after that, this pipe, whatever the pipe that is attached to the strainer, is called a suction pipe, which is used to suck water. And then this suction pipe is connected to the casing. Now we have already seen the function of the casing is it will hold the water for some time, like it will prevent the splashing of water when the impeller is rotating. Okay, and also it controls the pressure of the water. And inside this we have a impeller which can rotate in circular motion. This impeller has vanes which are curved in shape, and after that, to the other side of the casing we have a pipe that is called delivery pipe. Okay, this pipe is called delivery pipe, through which the water will come out at high velocity and high pressure. Okay, so with this we can pump the water. So here we have a delivery valve also, where we can operate this valve and we can get a large amount of water. So depending on the necessity, we can change the delivery of the water by operating this delivery valve. Simple. Now we have seen what are the different parts of a centrifugal pump. Now we will try to understand how does a centrifugal pump works. Now the centrifugal pump works when we have given some power to the electric motor. When we give power to the electric motor, it will try to rotate. Now the shaft connecting the electric motor and the impeller, it will transmit the power from electric motor. Now this impeller will rotate, which will make the water rotate. So this entire casing is filled with water. Okay, the entire casing is filled with water. Because of this, when we rotate the impeller, what happens? The water inside the casing will rotate at a very high speed. So this rotation can be used to increase the velocity and the pressure of the water. Okay. Now what happens is, so we'll try to understand how the working is done. There is a principle that is attached to this working of a centrifugal pump. So that principle is called a forced vortex flow. Here we have this forced vortex flow. So what is forced vortex? First of all, we should know what is a vortex. So whenever we try to rotate water, it will forms a circular motion, and at the center we can see the formation of a vortex, like a circular cylindrical shaped formation will be seen. Okay, suppose if this is a bucket and if I have water in this, if I am trying to rotate this water, we can see the formation of a vortex here. When the water is rotating at a very high speed, we can see the formation of vortex. That means a area is created at the center of the rotation where the pressure is less than the atmospheric pressure. Okay, or the pressure that is present here. Suppose if I take two areas, this is X and this is Y. When I compare the pressure at X and Y, the pressure at Y is definitely less than X. Okay. Now this is called vortex. Vortex means it is kind of like what we see in storms and hurricanes. A hurricane is an example of vortex that is formed in air and clouds. So in water, if we try to create a vortex, so this is called a hurricane, like for water. Now, what is forced vortex? So when we try to create a vortex by using some kind of mechanical energy, then it is called a forced vortex. We can see here we are using some kind of electric motor for creating rotational motion. This rotational motion is being generated by a motor. So we are artificially creating this vortex. So what happens due to the formation of this vortex? A vortex, when it is formed, okay, now when we try to understand how the vortex is formed in this casing, this is formed in a vertical plane, not in the horizontal plane. It is formed in a vertical plane. That means the water will be rotating in this plane, vertical plane. Okay. Now when the water rotates in this direction, what happens? At this point, at the center of the rotation of the water, we can see the formation of the vortex. Okay, here the vortex will form. So what is the plane of this vortex? The vortex will be formed in horizontal plane. Okay, here the vortex will be formed. Now what happens is, we will connect the suction pipe at the center of the vortex. That means if this is casing, we will connect the pipe here. Now this pipe is connected perpendicular to the rotation of the vortex. Okay. Now and it is merged into the water in the sump. Now what happens? Due to the vortex, we can see a pressure drop at the vortex area. So exactly at that point, we will connect the suction pipe to the casing. Now what happens? The water which creates a forced vortex, at the area where the vortex has formed, there will be negative pressure. That means a low pressure area is created. Because of this low pressure area, the water from the sump will be sucked into the suction pipe. Okay, the water from here, it will enter here into the suction pipe, because we have created a low pressure area inside a casing. So this entire thing is based on centrifugal force. So when we try to rotate the water, what happens? The water will rotate and it will form a vortex at the center. Due to the formation of this vortex, a negative pressure is created, and due to this negative pressure, the water from the sump is sucked into the casing and through the suction pipe. Now, when the water enters into this casing, the water will be displaced, like it will be continuously rotating. Whenever the casing is completely filled with water, what happens? When we open this delivery valve, the water will try to escape through the delivery pipe in this manner. So this is the simple working of a centrifugal pump, where a forced vortex is created in a closed casing, which will make the water sucked into the casing, and from there the water will be delivered through the delivery pipe. Okay. So now what is the force that is increasing the pressure and velocity of the water? See, in the sump, the water is at stationary level where it is not moving in any direction. Whenever we try to suck it through the suction pipe, the water will enter into the casing, and from there the pressure and velocity of the water will increase, particularly the velocity. So the water will come out through the delivery pipe with high velocity. This is done with the help of a centrifugal force, because we are continuously rotating the water at high speed. The water, while rotating, it will enter into the delivery pipe, and from there it will be delivered outside, so that we can like this pump can be used to store the water in a overhead tank which is of about 10 floors height. Okay, we can easily supply water from one place to another place, because we have created large velocity to the water with the help of impeller. Because the impeller is rotating, it will rotate the water at high speed, so the water will gain more velocity. So the pressure and velocity of the water is increased due to the rotation of the impeller, and that is how we will get a large amount of water by using a centrifugal pump. Okay, so centrifugal pumps are generally used for pumping the water from one level to another level, like ground level to some overhead tank, or from one place to another place. Like it can flow, you can make the water flow from through a long distance. Now let us see what are the applications of a centrifugal pump. There are many applications, like they can be used for pumping not only water, they can be used to pump oils. So in some kind of industries, we can supply or pump oils using these centrifugal pumps. okay, etc. We'll try to see what are the different applications. The first one is the benefit of using centrifugal pump is that they are simple machines. Because these machines are very simple, because they will have a moving centrifugal impeller and an electric motor. When these two are coupled together, we can generate a centrifugal pumping force. Okay, so these machines are very simple. They are no complexity, and they work well for applications that require large discharge and small heads. This is very important point. These machines, the centrifugal pumps, are used when large discharge is required, and also it can give only a small head. So in the previous lecture, when we are studying reciprocating pumps, we have seen what is head and what is discharge. Head is nothing but it is the height to which the water has to be supplied. Suppose if I have a centrifugal pump which will supply the water to a overhead tank which is presented at the 5th floor. Now the height from the centrifugal pump, that is at the ground level, to the 5th floor is called as head. The height between ground and 5th floor, this is called head. This is measured in meters or feet, head. And then Q is nothing but discharge. Discharge means how much amount of water is being pumped by the centrifugal pump. So this is also important when we try to use a reciprocating pump or a centrifugal pump. We should know how much amount of water has to be discharged, and also how much head the water has to be supplied. These two things plays a very important role when we are considering a particular type of pump. Now, in reciprocating pumps, we'll try to compare this. This is R stands for reciprocating pump and C stands for centrifugal pump. And also I am comparing these two. H stands for head and Q is the discharge. Okay. Now, in reciprocating pump, we can get very high head. We can get high head, whereas in centrifugal pump, we can get small head. Okay. That means the centrifugal pump can pump water only to a certain level, certain height. After that, this cannot pump because we are creating this height with the help of a rotating motion. That means the rotating motion of the impeller is causing the velocity. This velocity will not be as high as the reciprocating pump. And when we compare Q, that means discharge. When we compare the discharge is low in case of reciprocating pumps. Whereas in centrifugal pumps, the discharge is like very high. We can get more amount of water because we are continuously rotating the impeller so that we will get large discharge of water from the pump. Okay, this is the difference. So the centrifugal pump will have low head and high discharge. And third point is, it does not have any moving parts or valves, hence maintenance is easy. So here the only moving parts are the impeller and motor. So the remaining parts are not movable when we compare to the reciprocating pump, where we will have a piston, crank, piston rod, connecting rod, etc. There are multiple moving parts are there. Here there is only one moving part, the shaft and the impeller. Only the two moving parts. So maintenance is easy. And then centrifugal pumps can run at high speeds with minimal maintenance, compared to the reciprocating pump, which will have the conversion of motion from rotating to reciprocating. Whereas in centrifugal pump, we have only rotating motion that is directly given by the electric motor. So there is very less maintenance is required, and it produces a steady and consistent output. We will have a consistent amount of water discharge coming out of the pump. Because in reciprocating pumps, we will have pulses of water coming. Like in one motion of the piston, we will get water. And the other motion, like to and fro motions are there. In one motion, we'll get water. In other motion, we won't get any water. Where we'll have an idle motion. That means there is no water coming out of the pump. Okay. Now, they are highly flexible and can be repositioned them easily if needed. So, these centrifugal pumps are very compact and they can be moved from one place to another place. They can be installed at a particular place and they can be used. Okay, so these are the advantages, and because of these they have many applications. They can be used in wide range of applications in different areas. Now let us try to understand the differences between a centrifugal pump and a reciprocating pump. Now the first difference is the discharge is continuous and smooth in centrifugal, whereas it is pulsating in reciprocating. We have seen this. The water coming out of the reciprocating pump is in the form of pulses because we have an ideal movement of the piston inside the cylinder. The flow is not continuous unless we will use a double acting reciprocating pump, where we will get double the discharge while the piston is moving, so that there is no pulsating discharge. Okay, and the second difference is it can handle large quantity of liquid, and that means in centrifugal pump it can handle large amount of water, whereas in reciprocating it handles small quantity of liquid. So when we want to move or when we want to discharge large amount of water, we have to go for centrifugal pump. Okay, discharge is more. In reciprocating, the discharge is very low. And third difference is it is used for large discharge through small heads. This is all same, and it meant for small discharges at I head. So reciprocating pumps can pump water to higher heads, whereas centrifugal pumps can discharge large amount. Okay, discharge is more, and cost of centrifugal pump is less compared to reciprocating, and cost of reciprocating pump is approximately 4 times the centrifugal pump. 4 times. So the cost is very high in reciprocating pumps. That is why nowadays reciprocating pumps are not so used, because they have many moving parts and they require frequent maintenance, and their cost is also 4 times higher. And next difference is the centrifugal pumps runs at high speed, whereas the reciprocating pumps will runs at low speed, because we have to convert the rotatory motion into to and fro motion, that is reciprocating. So the speed is low. And then the next difference is efficiency is very high in case of centrifugal pump, whereas efficiency is low when we compare to centrifugal pump. Okay. And the next difference is it needs a smaller area and cost of installation is less. Okay. For the same amount of water to be discharged, the area required for this centrifugal pump is less when compared to reciprocating pump. That means reciprocating pump will require more area to be for the installation, whereas for the same amount of water to be discharged, we can use a smaller centrifugal pump. And then low maintenance cost, because there are very less moving parts in centrifugal pump. Here high maintenance, because we have lot of moving parts. And the next difference, the last one, is it can be used for lightly lifting highly viscous liquids, whereas this is used for less viscous fluids. When we want to move not only water, we can move other liquids like oils, petrol, etc. can be lifted with the help of these pumps. So the centrifugal pumps can continuously lift, they can be used for pumping high viscous fluids also. But reciprocating pumps are not used, so they can be used for less viscous fluids only. Okay. Now these are the differences between centrifugal pump and reciprocating pumps. Now we will try to understand what is the concept of priming. So priming is a concept where we will try to create a forced vortex. So when we are trying to start a centrifugal pump, we need a forced vortex to be created inside the casing. Okay. Now what happens is, when the centrifugal pump is in off condition, that means there is no movement inside the casing. That means what happened? The water inside the casing will be dropped into the sump. That means there is no water present inside this casing. Initially there is no water. So what happens? In this condition, if we try to switch on this centrifugal pump, the impeller will rotate, but it cannot create a vortex. Maybe it can create a vortex that is made up of air, but not water. We have to create a forced vortex that is made up of water. Okay, we need water vortex in order to suck the water from the sump. So a forced air vortex does not have enough suction pressure to suck the water. Okay, now here we will take water. Here there will be a priming port. This is a priming port where it is an opening valve into the casing, so that we can open this port and we can pour some water. When we pour water into this casing, the casing is now filled with water, like in this second picture. Okay, the casing is filled with water, and when in this condition, if we try to switch on the centrifugal pump, now the centrifugal impeller will rotate along with the water. Previously there is no water, so that we have filled some water inside the centrifugal casing, and when we try to switch on this motor, the impeller will rotate water. Now we can form a forced vortex inside water. So this process is called priming. Now due to the forced vortex that is created inside the water, this will create a force or suction which will suck the water from the sump into the casing. Okay, so the concept of priming is simple. Priming is nothing but filling the casing. Whatever the casing is there, we have to fill this casing with water before switching on, so that the casing is completely filled with water and it can create a forced vortex inside the water, which will create a suction, so that water can be easily pumped. Okay, because these centrifugal pumps are very compact, sometimes they has to be removed and they has to be installed at a remote location and they can be used. So whenever they are installed for the first time, and whenever we try to start them after installation, they need some they have to be filled with water in order to create suction. So this process is called priming. Filling the water inside the casing is called priming. This is done before the first time. If we are trying to switch on the motor for the first time after so long, or after reinstallation or installation, so we have to do priming in order to create suction inside the casing. For the next time, there is no need. Maybe if the water is present inside the casing, there is no need to do priming. If the water is not there inside the casing, we have to pour some water from through the external port, through which we can create suction inside the casing. So this is all written here. So priming is the principle of filling the suction pipe casing with water through external source, so that it can create a forced vortex and it can create suction which will suck the water from the sump. Now that is all for this lecture. We have studied the working of centrifugal pump, different parts, and we have studied the concept of priming. We'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.